Okay, this is the solutions for the sets and probability review mock exam. Number 100 students were asked what they had for breakfast on a particular morning. There were 3 choices: cereal, bread, fruit. It is found that, and it lists a bunch of characteristics of this distribution. Represent this information on the Venn diagram. So there is the cereal group, also known as X, the bread group, also known as Y, and the fruit group, also known as Z. We're going to put that in the Venn diagram. Okay, so there's C, there's B, and there's Z. So cereal, bread, and fruit, also known as XYZ. 10 students had all 3. That goes in the middle. 17 students had bread and fruit only. 17 there, between bread and fruit. 15 had cereal and fruit only. That would be between cereal and fruit. 12 students had cereal and bread only. That would be between cereal and bread. 13 students only had bread. 8 students only had cereal. And 9 students only had fruit. Okay, so I think we're okay. One thing, is there anybody outside the circles here? Well, the way we figure that out is we know that the total number of students is 100. So if we add up all these numbers here, do we get less than 100? And I don't think we do, because if we look at B, they're already asking the number of students who had none of the 3 choices for breakfast. So I don't think that I don't think it's going to add up to 100. Let's see what it adds up to. Let's see, 10 plus 17 plus 15 plus 12 plus 13 plus 8 plus 9. That gives me 84. So there's 84 people accounted for here. So there must be 16, 100 minus 84 outside. Oops. 100 minus 84 equals 16. Okay. Write down the percent of students who had fruit for breakfast. Okay, so fruit for breakfast would be anybody inside the fruit circle. So that would be 15 plus 10 plus 17 plus 9. Let's add that up. 15 plus 10 plus 17 plus 9. That gives me 51. So that's 51 students. It says write down the percentage. So that would be 51 divided by 100, which is 51%, okay, or 0.51. Describe in words what the student in the set X intersect Y prime had for breakfast. Remember this symbol is complement, Y complement, so not Y. The only reason why this is hard is because they gave the names X, Y, Z instead of C, B, and F. If this was C, B, and F, it would be a little easier. So this is actually equal to C intersect B complement, which means the student in this set ate cereal but did not eat bread. Or you could say something like ate cereal and did not eat bread. Something like that. Okay? Find the probability that the student had at least 2 of the 3 choices for breakfast. So that would be anybody in the little triangle here. Anybody who had at least 2 of the 3 choices. So that would be 12 plus 10 plus 15 plus 17. 12, let's add that up. 12 plus 10 plus 15 plus 17. 54. Okay, so that would be, and they asked for the probability, so we need to put 54 over 100 because it's 100 total kids. Okay. So now find the probability that the student had at least 2 choices for breakfast given that the student had fruit. So if we look at the diagram here, we're talking about him having one of these 3 given that he was in this circle. Okay, so in the numerator we would have 15 plus 10 plus 17, and the denominator we would have everything in this circle. So actually we already figured out the whole circle, right? Because we already figured out the probability he's going to have fruit. It was here, 51 over 100. So the denominator here is going to be 51 over 100. The numerator is going to be, let's see, 2 or 3 choices and had fruit. So that would be 15 plus 10 plus 17. 15 plus 10 plus 17 divided by 100. Okay, so let's simplify that. 15 plus 10 plus 17 is equal to 42. So 42 divided by 100 over 51 divided by 100, and then we just get rid of the hundreds and we end up with 42 divided by 51. Oops. 42 divided by 51. Okay? Next problem, number 2. A survey was carried out in an international airport. A number of travelers were interviewed and asked for their flight destinations. The results are shown in the table below. Let's see. So it's divided into males and females and where they were going. If you add up all these numbers, we're going to get the total number of travelers. Let's add up the columns and rows first, and you'll see why that's convenient to do. 45 plus 35 is 80. 62 plus 46 is 108. 37 plus 25 is 62. 45 plus 62 plus 37, 144. 35 plus 46 plus 25, 106. Okay, and then if we want to find the total, it would be either 144 plus 106, 250, or we could add up these, 80 plus 108 plus 62, we should also get 250. One traveler is to be chosen at random from all these interviewed. Find the probability that the traveler was going to Africa. So Africa would be 62 plus 46 equals 108, right? So 108 people are going to Africa. The probability that you would choose someone going to Africa would be 108 divided by the total number of people, 250. Okay. One female traveler is to be chosen at random from all the interviewed. Find the probability that this female traveler is going to Asia. Okay, so let's see. Probability that this female traveler is going to Asia. All right, so one female traveler is chosen at random. So they already chose a female traveler. So that would be out of 106, right? So there's 106 female travelers. And then it says, find the probability that this female traveler was going to Asia. So that would be only 25, right? So that would be 25 out of 106. It wouldn't be 25 out of 250 because they said that they already chose the female traveler. So it's already narrowed down to 106. It's not 250 anymore, okay? It's like saying, find the probability that this female traveler is going to Asia given that a female traveler was chosen. Now last one. One traveler is chosen at random from those not going to America. So how many would that be? So not going to America would be the people going to Africa and the people going to Asia. So that would be 108 plus 62. 108 plus 62. That would be 170 people not going to America. So, okay, so one traveler has been chosen at random from the 170 people not going to America. Find the probability that the chosen traveler is female. Okay, so there is basically these two groups, so 46 and 25. 71. So there's 71 women going to those two countries. Okay. All right. Number 3. Sharon and Lisa share a flat. Sharon cooks dinner 3 nights out of 10. If Sharon does not cook dinner, then Lisa does. If Sharon cooks dinner, the probability that they have pasta is 0.75. If Lisa cooks dinner, the probability they have pasta is 0.12. So, if Sharon cooks dinner, it was 3 nights out of 10, right? And so Lisa is the rest. Okay, and then if Sharon cooks, 75% of the time she cooks pasta. The rest of the time it's not pasta, 0.25. When Lisa cooks dinner, there's a 0.12% it's pasta, and the rest 0.88, because 1 minus 0.12 is 0.88, is not pasta. Okay, so it's Sharon pasta, Sharon not pasta. When you put the bar over it, that means not. Lisa pasta, Lisa not pasta. Okay, so these are the 4 things that can happen. Sometimes it's easier just to multiply everything out. So this is going to be 0.3 times 0.75, which is 0.225. And this one is going to be 0.3 times 0.25, which is 0.75. I'm sorry, 0.075. Okay. And then this one's going to be 0.7 times 0.12, which is 0.7 times 0.12 is 0.084. And then this one is going to be 0.7 times 0.88, which is equal to 0.7 times 0.88, 0.616. Just to check, we can add up all these and see if they add up to 1. They should. So 0.225, 0.075, 0.084, and 0.616. And they do add up to 1, so those are correct. All right, find the probability that Lisa cooks dinner and they do not have pasta. So it's Lisa P not. So that would be this one. So that's just 0.60616. Find the probability that they do not have pasta. So that would be Lisa do not have pasta plus Sharon not pasta. So that would be Sharon not pasta is 0.075. Lisa not pasta is 0.616. Okay, so that would be 0.616 plus 0.075, 0.691. Okay. Given that they do not have pasta, find the probability that Lisa cooked dinner. Okay, so this is a conditional probability. So given that they do not have pasta, find the probability that Lisa cooked dinner. So it would be Lisa not pasta. So given, so we're going to have, I'm sorry. Yeah, it would be probability that Lisa. Okay, so this is equal to the probability that Lisa not pasta over the probability of not pasta. Okay, so we know that the probability of not pasta is here, okay, which is 0.691. And we know that the probability of Lisa not pasta is 0.616 from B. So we just divide these two. 0.616 divided by 0.691 is 0.891. Okay, and that was it.